In continuation to the theory of correlation and regression, we just discuss a few more things about the regression and lines of regression as well as regression coefficient. So we saw that A1 and B1, the product of A1 and B1 is equal to R square, and R is equal to under root of A1 B1, which represents the geometric mean between the two regression coefficients. And hence we conclude that the lines of regression intersect at x bar comma y bar. They intersect at x bar comma y bar means they satisfy the particular given equation of a line. So there are certain points to be noted. What are they? If R is equal to 0, the two lines of regression become y is equal to y bar and x equal to x bar. See, the line of regression x on y is given by x minus x bar is equal to r into this into y minus y bar. So when r is equal to 0, this RHS is going to be 0. So we get x minus x bar is equal to 0, and that means x is equal to x bar. Similarly, for the regression line y on x, it will give you y is equal to y bar. So when r is equal to 0, the two lines of regression become y equal to y bar and x equal to x bar, which are two straight lines parallel to x axis and y axis respectively and passing through their means y bar and x bar. So when r is equal to 0, the lines are parallel to x axis and y axis passing through their means, and they are mutually perpendicular. So in general, when r is equal to 0, what is the nature of regression lines? Nature of regression lines is they are perpendicular to each other. When r will be equal to plus minus 1, the two lines of regression will coincide. R is equal to plus 1 or r is equal to minus 1. In that case, I say that the two lines of regression will coincide with each other. Will coincide with each other means they will be one and the same line. So that is what, these are the important points which are to be noted for the or in regard with lines of regression. Now there are certain properties related to the regression coefficients. We discussed or labeled regression coefficients as correspondingly A1 and B1. A1 will nothing but be the regression coefficient of line y on x. So it is denoted by r into sigma y upon sigma x. What is B1 denoted by? R into sigma x upon sigma y. So what are the properties of regression coefficients? Always remember, if one of the regression coefficient is greater than unity, the other must be less than unity. Means one of the regression coefficient, the value of this A1 and B1, if it is greater than 1, other should be less than 1. The arithmetic mean of regression coefficient is greater than the correlation coefficient. This first point is usually to be kept in mind so as to take the decision whether which regression coefficient is going to be for the line y on x and for the line x on y. The regression coefficients are independent of origin but not of scale. Here they are mentioning that regression coefficients are independent of the origin but not of scale. Correlation properties, it is independent of origin as well as scale. Regression coefficients are not that same. The correlation coefficient and regression coefficient will always have same sign. Correlation coefficient always lies between -1 and 1. So if correlation coefficient is negative, then regression coefficient will also have the same sign. If correlation coefficient is positive, the regression coefficient will always be positive. So A1 and B1 both will be positive. Their product is positive, and therefore R is equal to under root of A1 B1 is always positive. If R is negative, A1 and B1 will again both be taken as negative, and A1 B1 product of two negative quantities will become positive. So that is how we try to find out the sign which will be same for correlation coefficient and regression coefficient. So these are certain important properties which are to be kept in mind. Either direct questions can be asked on them, or while solving the example, these points will help us to proceed further for the complete general or detailed solution. One more term or one more quantity what we can calculate for the given lines of regression is the angle between the two lines. So angle between the two lines of regression, which will always be an acute angle, is denoted by theta. So if theta is an acute angle between the two regression lines in case of two variables x and y, given by tan theta is equal to 1 minus r square upon r into sigma x into sigma y upon sigma x square plus sigma y square, where r, sigma x, sigma y have their usual meaning. What do you understand by usual meaning? R represents the regression, R represents the correlation coefficient, sigma x represents the standard deviation for the variable x, sigma y represents the standard deviation for the variable y. So accordingly we will be having the usual meaning for the notation sigma x, sigma y. What is sigma x square? It is variance. Yesterday only or the previous class we saw variance represents the measure of dispersion. So sigma x square, sigma y square represents the measure of dispersion or scatter. Its positive square root is nothing but the standard deviation. So angle between the two lines of regression is acute angle denoted by theta, calculated by or given by tan theta is equal to 1 minus r square upon r into sigma x into sigma y upon sigma x square plus sigma y square, where r, sigma x, sigma y have their usual meaning. Now again, depending on the nature of theta, we have categorized it into two different cases. What is case 1? When r is equal to 0, 1 minus 0 upon 0, 1 by 0 is infinity. So tan theta is equal to infinity. Theta is equal to pi by 2. When theta is equal to pi by 2 means 90 degree, the two lines of regression are perpendicular to each other. And before this also we saw, if r is equal to 0, the lines are intersecting through their mean x bar y bar and they are parallel to x axis, means lines are perpendicular to each other. So when r is equal to 0, tan theta is infinity, theta is pi by 2, lines of regression are perpendicular to each other. Here only we saw r is equal to 0, they are mutually perpendicular, the lines are parallel to x axis and y axis, means they are perpendicular to each other. And same is the quantity we are talking over here. When r is equal to plus minus 1, tan theta is equal to 0 and theta will be 0 or pi. When theta is equal to 0 or pi, the two lines coincide and there is a perfect correlation. This we have discussed. When there is r, the value of r as plus 1, it is perfect positive correlation. When value of r is minus 1, it is a perfect negative correlation. So in general, whenever I have the value for r as plus minus 1, the theta is 0 or pi, tan theta becomes 0. Two lines coincide and there is a perfect correlation. Just to sum up or to summarize, we have the set of important formulae for you. So correlation coefficient R will be summation xy upon under root of summation x square into under root into summation y square, both combinedly taken into under root sign, where sigma x square is summation x square upon n, sigma y square, which is variance, is summation y square upon n. The equation of line of regression y on x is y minus y bar is equal to, I told you y on x means in the denominator it will be summation x square. So it is summation xy upon summation x square multiplied by x minus x bar. Y minus y bar in other terms can also be written as r into sigma y upon sigma x to be multiplied by x minus x bar. The equation of regression line x on y, x minus x bar is summation xy upon summation y square into y minus y bar. So it is x minus x bar is equal to r into sigma x upon sigma y multiplied by y minus y bar. What is it called as? This is called as A1, regression coefficient of y on x. This is B1, r multiplied by sigma x upon sigma y, regression coefficient of x on y. So these are the important terms or formulae to be kept in mind for further simplification of the problem. R is equal to under root of A1 into B1, that is geometric mean of the product of two regression coefficient. So this is all the theory part related to regression and regression lines, properties of regression